Hi guys, my name is Pratik Mehta and today we are going to explore what is a tree data structure. So let's get started with chapter 1, the basics. Imagine turning a tree upside down. Now the topmost level represents its root. Then the tree branches out into child levels or child branches, and at the lowest level are the leaves. Now let's compare this tree with the digital representation of tree data structure in computer science. We'll walk through each of the component in a tree data structure. So now let's jump on to the computer representation of tree data structure. So tree data structure in computer is also a hierarchical data structure where each point of data is called a node. So 3, 11, all these circles are called as nodes. The topmost node is called a root node. The root node is the singlemost node where everything starts, and it does not have any parent, right? It does not have any parent. So it is the topmost node, and all these nodes are connected with each other, which are known as edges. So these lines are known as edges, right? So 11 is connected to 3 via this edge. Similarly, 11 to 19 via this edge. So all these lines are known as edges. And every node has one connecting node above it except the root node. So every node has one node connecting above it. So 8 has 3 above it. So 8 becomes the child of 3 and 3 is the parent of 8. So 3 is the parent of 8. Similarly, 8 is parent of 16. As 8 is parent of 16, so 16 becomes child of 8. So these nodes that are sharing the same parent are known as siblings. For example, 14 and 21, they share the same parent 9. 16 and 20, they share the same parent 8, right? And leaf nodes are the last nodes which don't have any children. So these nodes are the leaf nodes. Okay, they don't have any children and they are the last nodes in the tree data structure. So similarly, as we had seen the diagram earlier, so the last, if it's an inverted tree, leaves become the bottommost part, right? So here also leaves form the bottommost part of the tree, right? So now let's cover another concept or another terminology of a tree data structure, which is the height of a tree. So what is the height of the tree? The height of the tree is basically the length of the longest path to the leaf. Now what is a path? Path is a sequence of nodes and edges connecting a node to a descendant. So sequence of edges, right? So this is an edge, this is an edge, this is an edge, this is an edge. This forms a path from 3 to 7, right? This is a path. Similarly, this is an edge, this is an edge, this is an edge. So if we have to go from 3 to 21, this becomes the path, correct? So now what is the height of the tree? The height of the tree is the length of longest path to a leaf. So this is the longest path, right? If we want to see the height of the complete tree, right? Because 7 is the bottommost leaf and we have 1, 2, 3, 4 edges. We don't have so many edges connecting to any other leaf. So height of the tree becomes 4. So this is the longest path, 1, 2, 3, 4. Height of the tree becomes 4. Now let's take another example. So in this example, we will just consider the height of a particular node. So the height of a particular node, right, is the distance between node and its farthest leaf. So here let's consider this example where we calculate height of 9, right? So in this, the farthest leaf is just one edge away from 9. So here the height of 9 is 1. Similarly, let's take another example where we calculate height of 11. So height of 11 is again, if we consider the longest path and the number of edges till its leaf. So this is not the longest path, right? It has only 1 and 2 edges. This becomes the longest path, and if we see the number of edges, 1, 2 and 3. So the height of 11 is 3. if we consider another example where we calculate height of 5. Now 5 is a leaf node. There's no children to that. So height of any leaf node should be generalized to 0. So height of 5 is also 0 because there are no further nodes attached to it. So let's consider one more example where we calculate height of a node and height of a root node, right? So what could be the height of the root node? So height of the root node is the height of the tree. As we said, any node is the height till it reaches its leaf node. The number of edges determine the max number of edges determine the height of a node. So height of the root node becomes the height of the tree. So root node is 1, 2, 3 and 4. So height of the tree was also 1, 2, 3 and 4 because 7 is the farthest leaf node from the root. So height of root node is also equal to the height of tree, which is equal to 4. It cannot be any other node because there are very few edges compared to 7, right? So if we see 1, 2 and 3, if we see 5 leaf, it is only 3 edges. If we see 21 leaf node, it is only 2 edges. So that is lesser than 7. So height of the root node should be the farthest leaf node. So 1, 2, 3 and 4, which is also equal to the height of tree. Now let's proceed. As we said earlier, the height of any leaf node is equal to 0 because there are no further leaf nodes attached, right? So it is the bottommost node is called the leaf node and it should be 0. So how about if we generalize the formula, right? If we have to determine the height of a node using a formula, it should be height of any node is 1 plus maximum child node height. So let's consider the height of 11. In this case, let's consider the height of 11. So if we know the height of 19, right? What is the maximum height of 19? It is obviously 1 and 2 and not just 1, right? If we consider 5 leaf node, it is just 1. If we consider 7th as a leaf node, and height is to be taken into account by farthest leaf. So 1 and 2. So height of 19 is 2, and if we do plus 1, it becomes 3. So 1, 2 and 3. So height of 11 is 3. So this formula is 1 plus maximum of child node height. So maximum of child node height is 2, right? Not 1 but 2, and plus 1 is 3. So 1, 2 and 3. Now there is one more concept before we move on further. So similar to height, there is also a depth of a node. So if we reverse, right, consider this arrow, right? So if we consider this arrow, we have depth of a node. So distance of node from the root node. So we have to see from the bottom up. So the depth of root node is 0 because the definition says distance of node from the root node. So root node distance from itself is 0. So root node the depth is 0. Now if we consider 11, right? So 11 depth would be 1 edge, right? So this is the root node, 11 would be 1 edge, so it becomes depth is 1. So similarly, all its neighbors depth would be 1 because they are only same distance away from the root node. Now if we consider 19, depth is 2, 1 and 2 edges from the root node. So depth is 2. Now if we generalize this to a formula, it becomes depth of parent. Let's say if we are calculating depth of 19, so we have depth of parent 11, 1, right? 1 till root node is 1. So depth of parent plus 1 becomes 2, right? So depth of any node is equal to depth of its parent plus 1. So here plus 1 becomes 2 The depth of 19 is 2 till it reaches the root node. So that's it for this video. We'll be covering more such concepts and diving deep into the types of trees and the problems related to tree data structure in our upcoming videos. So please stay tuned. Do like this video, share this video and subscribe to my channel for more such videos. Thank you so much for watching.